A few problems first appear quite difficult or confusing when they're you're just looking around for some type of solution, any kind of footing. And max area of island, I think at first was one of those for me. The idea is that you have a grid or matrix of zeros and ones, where 0 is representation of water and 1 is representation of land. And the idea is that all the ones that are connected horizontally or vertically are all part of the same island, and our goal is to capture the island that has the biggest area. In this case, it looks to be right around the 4th row and the 5th row down into the 6th row of ones over here where I've highlighted. It's kind of hard to show. Nonetheless, so we're going to try to solve this kind of elegantly, and using a tool or a template rather that you'll be able to use for a lot of other problems, a lot of other problems that are very similar to this one. And typically when it comes to a grid or a matrix, I like to start with first taking the dimensions of that grid or matrix and saying mn equals len of grid, that's the number of rows, len of grid 0 is the length of that first row, which is ultimately then the number of columns. All right. So we're going to need some type of search function. We'll call that land size. And for now, we'll keep that empty. And then, of course, we're going to need to traverse this in some way. So for I in range m, for j in range n, do something. And of course, remember, we need to remember when we're traversing this grid, we need to remember which island we're on. So ultimately, to make them unique, right, in some way, to tell our process, hey, you need to remember that this is all part of the same island, and not to replace a previous island's size with this island. Ultimately, to keep these unique islands as their own size. So we say, okay, let's do that. K equals I, j as a tuple, and that is what's going to go into our dictionary. Let's revisit land size momentarily. Okay, so this is where the cool trick comes in. Land size, we want to be able to take in I, j, and then which island we're dealing with. Okay, that's that ij tuple that we first run into. That's going to be dealt with shortly. So we say if I is less than 0 and or j is less than 0, or I is greater than or equal to m, or j is greater than or equal to n, or grid ij is 0, or grid ij is 0, return. The reason we want to do this is that if I or j is outside of the bounds of anything that we can check inside of that grid, we don't want to continue the process. We'll get an error, right? Or grid ij is 0. This is interesting. Why would grid ij be 0, right? Well, in the first case, it's 0 when it's water, right? In the case we're using it for is we're going to use it as a placeholder. And to say we want this function to handle ones by saying grid ij, if it's a 1, that means it didn't return from here and everything passed. It's both valid inside of the bounds and it's a 1, it is not a 0. Grid ij equals 0. We'll turn it into a 0 because what we want to do is say dk, that dictionary above, equals d.get k0 plus 1. What this says is dictionary, get k for me. If it's not in there, return 0. If this becomes 0, remember we're adding 1 to it. If it doesn't return 0, we have the size of the island thus far that we processed, and we're adding 1 to that to continue to compute the size of that island. Now this is a recursive function that we're going to want to implement, so we'll say land size I j minus 1 k. Now this is where the neat trick comes in. You'll see this a lot in a lot of the programming videos that are floating around with similar problem types like this one. And what we're going to want to do is remember the islands are only connected forward directionally, horizontal and vertical. Okay, so we need to be able to cover that in our ultimately a depth first search, right? By saying, okay, check ij minus 1, ij plus 1. We want to check I minus 1j, and then we want to also check I plus 1j. And of course we want to pass in k, because remember that is the thing that we're using in our dictionary to identify the island kind of like the island's ID, the tuple that identifies the first island, the first instance of that island that we run into, where it's a 1. And how we'll identify that is by saying if grid ij equals 1, then land size of I, J, and K. So what will happen is we perform a depth first search on the island when we run across its first 1 in the grid, and then we perform that depth first search by going through all 4 directions until we see no more 1s, and we continue to add 1 to the size of that particular island in our dictionary. So now we've got all the sizes of the islands in our dictionary. What we want to do is to determine how big is the biggest island. Now, first of all, if we don't have anything in our dictionary, then that means we haven't seen a 1. Our algorithm hasn't seen a 1, so we just want to return 0. Otherwise, we have something in our dictionary, and we'll say return max dk for k in D. We run, accepted, submit, outstanding.